All right, you guys remember this one? It's been a year and a half, and it's been sitting. And I just kind of want to wrap up loose ends of old projects. I kind of got sidetracked, fell by the wayside. So, we're almost done with this thing. Like, we're literally like 10 welds away from being done, and there's no excuse to let it sit any longer, I figure. So this is our little RC forklift that we've been playing around with. And those are our forks and our potential size pallet and our two linear actuators. So, I'm not going to do the 4-wheel drive. I'll leave more room back there for batteries and stuff. So I'm just going to go for it. I think I can probably finish it in one day, and then I can test it out and see how all my design decisions pan out and how useful it is and how much power it has, and have a little bit of fun with it. Then I'll probably sell it or something. I don't know. So we're going to keep moving. So I guess we jumped ahead just a little bit. I blocked up the mast so we were perfectly perpendicular to the ground. Got the tires all inflated so I know I'm sitting right. I'm on a good section of floor. And then I clamped the forks in, and I just kind of welded them across the top and a little bit at the bottom. Took it off, welded it around as much as it needed, just a couple inches. We're only lifting like 50, 60 pounds probably. So now I'm getting ready to attach the lower linear actuator. Now, so I've contracted that to its smallest spot, and I'm going to figure out how much of a negative throw I want. Like if I'm going to be dumping things, so I got to put the bearings back. I got to put the bearings back on for that. But, how much of a negative rake angle do I want to be able to achieve? So with that fully retracted, I'll block the mask at the, max negative angle. And then we'll figure out a mount for the other end of that. And I'll just kind of tack it in light. Well, we'll get there. We'll get there. Hold your horses, boys and girls. Just realized I messed one thing up when I welded those forks on, perpendicular, those resting on the ground. I actually wanted to be able to give it like maybe 1 inch down travel in case the ground was uneven and I had to go a little bit extra lower than these tires. It's too late for that by welding on the top, but I could still do it by cutting the forks there and welding in like another inch. It'll be fine. I might not ever even need that, so whatever. And this surface rust that you see on everything, it's pretty light. I've already kind of brushed it off just with a hand brush. But this was stored in the garage, a heated garage the whole time. But in the spring, I keep it 66 or 67 and must cross the dew point once in a while. 'Cause it seems like this happens in the spring. Also, there was probably like sawdust and stuff sitting on top of it, which kind of captured the moisture and held it. So, it's not anything that'll cause a problem. It's just another stage of having to clean it before painting. So, kind of a pain in the butt, but that's what you get when a project sits. All right, so this strikes me as a pretty good angle for my max negative rake there. I think that'll be enough that anything would have a tendency to slide off, like if I was moving, I don't know, like rods or, I don't know, sound problem, who knows. And that turns out to be the linear actuator that's going to control that is 2 inch. And that actually puts us almost perfectly. 1 inch will be level. So then I'll be able to achieve that same angle going up. So this thing's like a pretty good balance. And for me to actually achieve that much of a dig angle, you can see just how far extended this linear actuator is going to have to be. So shouldn't be a problem. Should be okay. So we'll weld in a temporary bracket down in the bottom at this position. And then we'll do it once under power just to make sure for a sanity check. Then we can weld it in solid. All right, this video is as much for me as it is for you. I get to watch the angle that thing goes through as I Subtractor. Castleberries are max angle. Why? Oh, switch layers. So our linear actuator like really isn't even changing though. The arc is wide enough. We don't have to worry about toggle action. Awesome. So we have that all. We have a cross number clamped. I'm going to we ran it through our cycle, and it looks like our down angle's good, our up angle's good. We're not going to meet any more of either one of those. So a 2-inch travel was pretty much perfect. So I'll just give that a little tap and straighten that out just a tweak, and I'll weld that up. It's kind of a shame that I let this sit 1.5 years when I only had like this much left to do before it was basically running. I mean, all we had to do is put in a battery tray, connect a couple wires, and we're done. Oh, also, we're not going to need to lower those. I forgot that, the pallet sits up at least 3 fork thicknesses. So we can accommodate that much of a ground difference, right out of the box. So I think we'll probably be okay with that without dropping those forks any. Right, so all of our frame is complete. Now we have to worry about some weighting. So right now it takes very little. I mean, this thing is very pot heavy, as you would expect. The mast and the forks are, not to mention any kind of payload. So the leverage is going to work in our favor because the frame goes back farther than the forks stick out. I should probably measure that. It's not a whole lot, though. I have room for 2 batteries. I don't think I want to waste 2 batteries on this because, it's only 12 volt. And I don't think there's any scenario where we're going to be running this any long enough where we need 2 batteries worth of power. And so I'm going to put in an old battery. Or stick with me here for a second. Those forklifts they put on the back of, delivery trucks and stuff, 3 wheels, 3 points defines a plane. You could probably do a solid frame without any need for a pivot. And then I could just have one back there with a caster. And then that would let this steer even easier. Right now, as these go, it may try to, I guess it would try to skid those back tires around. So maybe one tire in the back on a swivel caster is the way to go, I think. So we can even fit 2 batteries in that light. And I'm thinking that without 4-wheel drive, without the real skid steer, we're not going to be able to steer like this. Like all the remote control cars, they always have front wheels that turn, right? So we're going to have to put a swivel caster on the back. So what I'm probably going to do is just cut that frame off at a decent distance back. It's a good thing I know this guy who goes to Florida and buys electric wheelchairs in the winter. Now they have some swivel casters. This is only half of them. So 1 tire in the back, not really going to cut it. We're going to have my target payload is like 60 pounds. So we're going to have like 60 pounds over that rear tire. And for a crawl space robot, we're going to be going over dirt and stuff. And there's no guarantee how firm that dirt is. So 60 pounds on that little tire on unknown soil compaction. Too shady. I'd want it double that. Which puts us into the ballpark of 1 caster per side, which will work. And then we're back to maybe needing a frame pivot, possibly. But a couple more thoughts. Sorry. I don't know if I'm going to have enough traction with those tires now with only 2. Maybe 4 would have been better. Skid steer probably wouldn't have had a very great turn radius, whereas, this is going to have a phenomenal turn radius. They don't want to be able to turn out of a dime. I might go with just 1 back caster for simplicity right now. just because I want to play with the dancing. It's been a while. The other thing I was thinking is, I could cut these two sides off, right? And then take two wheels and have them right next to each other, butted up, and then just extend this bottom plate. Whoosh. So, but I don't think it wouldn't turn as great as just one. I'm sure of that. And also, when the pivot, so you see the crown of the wheel, right? So there's nothing really like the sides of the wheel aren't going to dig in unless you are in pretty deep. It was pretty sunk in, which means that when the crown is right over the pivot, that's why you can turn super easy. If I have two of these, then the crowns aren't going to be over that center thing at all. So, you're probably going to have to start moving forward before you can get a turn going. So, I don't know. I think I'm just going to try one and play with it on concrete because, at this point, I don't even know if it's going to go in my crawl space. So, I don't know. Just start moving, do something. We know there might be some issues. We might revisit these decisions later. But at this point, I don't care. Just going to keep going. All right, so we got our battery tray in and welded on kind of a heavy-duty bar across the back in case I do a pivot thing. I'm going to try to do it just with one wheel in the back. So before I create any kind of contraction to hold that, and I'd probably want it, I'm going to still set my overall length and everything, right? Kind of, that'll be based on leverage, how far over that is. I kind of want that to be a little bit farther for counterweighting. So now, before I design how that's going to go out and balance, I need to figure out what I'm going to use for a counterweight. I've been looking in the line and the scrap price lead looks like it's 38 cents a pound. I can't find that anywhere. So I think I'm going to end up using old brake rotors. One of my friends is a mechanic at a garage and I can just get piles of them. So whatever I designed to go out there is probably going to be optimized for holding, brake rotors, or half, pieces. So I'm going to go pick up some of those and then we'll keep on. We're so close. We're so close. And also, I chose these maker motors because I wanted, an easy to use output shaft that was already with a flat on and everything, instead of the wiper motors that have the taper that was, you are always going to get a wobble. Well, these end up having a wobble. So, I have more time. This was supposed to be a quick project and, this was supposed to be a quick, cheap project. That's why I used these wheels, and it turned out to be not so cheap and not so quick, fairly quick. So since those have a wobble already, the direct drive thing kind of didn't pan out. The simplicity of the direct drive, I ended up with a wobble. So if it's too much of a wobble, if it's going to piss me off, then I'm going to go to gear drive, which simplifies, I'll have a lot more room in there and stuff. So anyway, and if I kind of almost don't remember why I used pneumatic tires over electric wheelchair tires, which I had a pile of. And then I could have used the hubs from an electric wheelchair and I had to go through all that. Why did I don't know. Those don't have any more traction than the electric wheelchair probably. Anyway, brake rotors. Next. One other note about, I picked up those tires because they were really unbelievably cheap. But there are so many dimensions built into this now based off of that tire size. And, and building those hubs was no small feat. So it's kind of stupid. I should have started with awesome tires instead of cheap tires, because so much gets built around the height offset of that, the mast offset, how much the forks go down, where the bearing is, the bearing height for those hubs, the amount of time I spend building the hubs, I guess it was a stupid thing to skimp on. I think they'll be fine. It's just could have been So we bought these for free. Some are just the rings, and a couple of them are the whole rotor. Got them stacked in a pretty tight way, but it's 11 inches. And, so that's where my caster would be. It's pretty far out there. I don't really want, I could do them vertical, but that's not really a great scenario either. I think what I might try to do is plasma cut all these in half and then stack them, a double thick like that. But because it's cast, I can't really use it like as part of my frame or anything. So I still have some of this old steel. It's pretty thick actually. It's a good solid 1/8 inch. And I can make a box, between those 3 pieces. It's just scrap. That's what I use for my battery tray, is some of the steel from the old zero turn stove. So if I build just a box back there, and I just can load it up with whatever I need, and then I can put the caster probably about there. That seems about right to me. And so then the question is, my buddy does have an entire box full of steel steel wheel weights and just chain and just garbage junk. Before I could, see how hard it is to cut that into pieces with the plasma cutter, how fast it goes. Because that's probably the right amount of weight. It's just in not the best format. And I've already spent some time pounding all the rust off, So we'll see which way we go. Ultimately, something like the box will be very easy just to take pieces in and out of. So I can kind of fine tune the weight. So we'll see. We'll see where it goes. Someone filled plasma fought out for hubs, and then they just cut him in half. Man, I was plasma cutting some in half, but I went in and started relaying. So I got them set up. They're just going in the van saw with about 10 teeth left on the blades. And here, just go from a file, and then I'm going to dunk those in, black paint or something. So they're pretty gassy. Probably would have been about $80 worth of leg. So when I started building my box for my counterweight, and this is all up there on the mini zoom. So there, we'll get that finished up, and that'll actually become part of the fling. Can't remember would I ever show you guys this. This is Lila. So for the bandsaw, that lower blade has a tendency to slip off sometimes because it's such a small diameter and it doesn't really have an awesome bevel on it. So I ended up making this of a piece of sheet metal. Horrible implementation, but it fucking works right. So, basically just weld it on a stud to the plate and then, placing tabs on it to catch the back of the blade. And then I tapped the center hole and then just put a little hub plate on and a screw with a lock washer, and that solved the problem dead. And, these Harbor Freight bandsons, I'll just throw this in real quick. This one is from 1998, and I bought a new, and I have been using it nonstop since then. So it's pretty amazing how such a cheap tool can last so long. So with the part where we're attaching the caster, if you're back, and you can see that, and so initially I ground, this had come down, I cut it off, and then I ground it trying to get it straight, but it wasn't really too precise. And I really want this bar to be pretty dead on, straight across from here, so that as this pivots, it doesn't have to pick all that weight up in order to pivot. It doesn't have anything trying to keep its orientation. So, even though I missed on my initial grind and weld, all I have to do is kind of, grind a notch and then bend, just leaving a little bit on the bottom. And then we're going to bend this up until we get just the right angle. And that way we can keep shaving it until it comes up. It's a little late in the game. Probably could have been a little careful when I tacked it, but here we are. Right, so we got the battery box welded on. Now it's part of the frame. We have everything set to level. And now we're going to take that back caster. We're going to take our little level, put it on there, and we're going to go right through the battery box. Probably going to do an upright post with one down to brace it. And then our frame will be, complete for the initial rub in area. Right, so battery box is essentially part of the frame. We have our wheel going through. We have it reinforced on the top. 3 little bars that may cross the bottom and have, little bits of gusset. I'm debating whether I need to put in the gussets here. Won't hurt. Probably will. But now we're far enough along, so this video is getting kind of long, but there's one more thing that I want to do. Next video will be wiring and RC testing. So for the final part of this video, I think I want to test, how much it takes to tip it, then how much counterweight I need in the back. So we need to test that now. That much weight is we're just about, rarely takes anything. So that's pretty evenly balanced now. Gonna weigh that, see what we got for payload. I mean, that's too much at this point. So that's a 50-pound payload. I haven't bothered to weigh that yet, but I mean, our ballast box is basically full. I did order some lead, so I might put some lead in the bottom to get a little bit more density, but I don't know. So it'd be about probably 45 pounds would be safe at current. But it's really just a matter of ballast. But it'll also be a matter of how much traction we can get, right? How much are those motors strong enough to move? Because right now we're probably looking at, the frame's probably 80. Actually, I should weigh the frame, but I'm guessing 80, 50. So we could be, those motors, we're asking them to move 150 pounds. So we may have to put gears on there just to gear it down some. We'll see. That comes when we get to the electrical part and get the thing moving. But frame-wise, for our first stab in the dark, I'll call this version 1.5 because we did modify it from the 4-wheel drive. But next, we'll get the electrical and get it moving, see about traction and handling on dirt and turning radius and all the good stuff. So still more to come.